2.
In our study of radioactivity, we need to study what's called radioactive decay. And what you see in front of you are two graphs, one that models growth and one that models decay. We're going to start by looking at the graph for growth and then deconstruct what decay will look like. We've already seen graphs like this. We've had this part of the graph in a quiz. So let's go carefully through it. The graph is y of x is 2 to the x. It's a model for the heat close to a Bunsen burner. So when we're close to the Bunsen burner, it's hot. And when we're far away, it's cold. So let's actually go through this numerical model of how the heat changes as we move far away from the Bunsen burner. When x is equal to 2, then we have 2 squared. 2 to the power 2 is 4. Then 2 to the power 1 is 2. 2 to the power 0 is 1. And then we got to go to the negative numbers. 2 to the negative 1 is a half. That's a half right there. And 2 to the negative 2 is a quarter, halfway again. So let's put a quarter there. So that's the model as we go from hot to cold with the Bunsen burner at the right end of the rod. Let's go the other way now. You can see the Bunsen burner is between two rods. So now we're heating the left end of the rod. The left end of this rod is hot. So let's look at the graph. When x is negative 2, it's 4. When x is negative 1, it's 2. When x is 0, we have 2 to the 0, which is 1. When x is 1, it's a half. And when x is 2, it's a quarter. What do you notice about these two graphs? Well, if I take this graph and flip it around, of course, I get the mirror image, this graph. When I flip this graph around, positive x goes to negative x, and negative x goes to positive x. And that's exactly what you see at the table. The resultant values are flipped upside down. So what is the relationship for the amount of heat in terms of our model? It can't be 2 to the x, because that would just make it the same as this, which is this graph. But it's backwards. And the way we write x backwards is we put in negative x. We now have a model for decay. And when we study radioactive decay, we'll start with x equals 0 from 1 and go down. And the reason is that this actually models the beginning of what we have, which is a whole package. It could be a bigger number, but starting at 1 and going down is sufficient for our analysis of radioactive decay.